In level 4, we will be working with parallel and perpendicular lines. And the key with parallel and perpendicular lines is that two parallel lines have the same slope and two perpendicular lines have opposite reciprocal slope. So, for example, if one line had a slope of 2/3, the opposite reciprocal, two things change. The perpendicular slope would be the opposite, meaning change the sign. My original slope was positive, my new slope is negative. And then reciprocal means we flip the fraction. So I would flip 2/3 and make it 3/2. So that's an example of two perpendicular slopes. Okay. In this example, it says line M can be represented by the equation 3x plus 6y equals -4. Write each linear function below. In part A, we want to write a linear function that's parallel to line M and has a y-intercept of 5. Well, with line M, I don't know its slope yet because of the form it's in. So I need to solve for y and put it in slope-intercept form so I can tell what the slope is. So I'm going to zoom in a little bit, 3x plus 6y equals -4 is my line. I want to solve for y, so I'm going to subtract 3x from both sides. And I get 6y equals -3x minus 4. And then I would divide by 6, and I divide everything by 6. And we get y equals, I can reduce -3/6, that's -1/2 x. And then I can reduce 4/6, that's -2/3. So the slope of line M is -1/2, the number in front of x. Now I'm trying to write a new function, g of x, that's parallel to line M. So it's going to have the same slope of -1/2. So it's also going to be -1/2 x. But then this new line is supposed to have a y-intercept of 5, so I just do +5. And there's my perpendicular line. In part B, we want to write a linear function, h of x, that's perpendicular to line M and contains the point -4, 6. The slope of line M was -1/2. The perpendicular slope is going to be the opposite reciprocal. Since my original line had negative slope, my new slope is going to be positive, and it's going to be the reciprocal, so I flip the fraction, and we get positive 2/1, or just 2. So now I want to write the equation of a new line with a slope of 2 and the point -4, 6. So I can use point slope form for that, since I know a point and the slope. Y minus y1 equals m times x minus x1. And we get y minus 6 equals 2 for the slope, x minus the x coordinate of the point, and since it's minus -4, I'm going to do +4. And for this one, it didn't say to put it in slope-intercept form, so I could just leave my equation in point-slope form. If it did ask for slope-intercept form, and usually in function notation, that's what we want, we would distribute, and we get y minus 6 equals 2x plus 8, add 6 to both sides, and we get y equals 2x plus 14. And then to write this in function notation, instead of y, we would say h of x equals 2x plus 14.